using the Pythagorean Theorem and a quadratic equation to find side lengths of a right triangle. So this is just, it's another word problem for us to practice our word problem skills, right? Interpreting and building a model and all that fun stuff, but then also practice solving quadratic equations. And we're going to use the Pythagorean Theorem, which I've got over here. So the legs of a right triangle are the A and the B. So it doesn't really matter which is which. I drew this with the shorter leg being A, so I'll just kind of go with that. So the two legs make the actual right angle. And then the C is the hypotenuse, and that's always the longest side. And A squared plus B squared equals C squared. That's the Pythagorean Theorem. Okay, so they gave us some information relating A and B and C in a different way. So we're going to see if we can kind of write a single equation with just one variable using all of this information. So we have the shorter leg of a right triangle is 6 meters shorter than the longer leg. So A is 6 meters shorter than B. The hypotenuse, that's our C, is 6 meters longer than the longer leg. So C is 6 meters longer than B. Find the side lengths of the triangle. So I'm thinking that it might be easier to actually use an X. So I'm going to let X be the length of side A, or the shorter leg. So length of side A, which is our shorter leg. I'll just put short leg. So then, I don't know, I feel like to me this is going to make it easier to kind of understand how everything relates, but you could just let it be A if you wanted to. Okay, so if that's what I'm doing, and I know that this X value, A, is 6 meters shorter than the longer leg, so I can write the length of the longer leg, the B value, I can write that would have to be X plus 6. And then hypotenuse is 6 meters longer than that. So C, the hypotenuse, is add another 6 on. So it's 6 meters longer than the B, but we're going to use X plus 6 for B, so then plus another 6. So we've got then that our three side lengths are, so I'll put A equals here, X, X plus 6, and then X plus 12. So let's put X, X plus 6, and X plus 12 into the Pythagorean theorem for the A, B, and C. Okay, so A, we're calling that X. I don't know if that's a good idea. Maybe I should have just left it as A. And then plus, so X squared, right? So then plus B squared, X plus 6 is B squared. And then equals X plus 12 for our C. Okay, so now we have to solve this. And I'm trying to think if there might be a clever way, like a tricky way to do it without having to multiply everything out, but I don't think there is. So let's just go ahead and multiply it all out. Let's see, so I'll just kind of FOIL everything out. So X squared plus, okay, so X squared plus 6X times 2 is 12X. Plus 36. Now, if you don't remember that little trick, you can just write it out as the two sets of parentheses and just kind of distribute to get that. And then over here, X squared, multiply the two together, 12X, but double it, so 24X. And then plus 12 squared is 144. All right. So we can combine the X squareds over here, so I'm going to go ahead and do that. And then plus 12X plus 36 equals X squared plus 24X plus 144. So this is a quadratic equation because we have these X squared terms. So let's get all our terms on one side. I think it's easier if the X squared term ends up being positive. So I'm going to sort of move everything over to the left. So I'm going to subtract X squared from both sides. and then subtract 24x from both sides, and subtract 144 from both sides. Okay, so we'll have x squared minus 12x minus, oh dear, okay, 8, I think it's 108, is it 108? I think that's right, 8, 14, yeah, equals 0. Okay, so now you can use whatever method you want to finish this. You can factor it, that's what I'm going to do, or you could use the quadratic formula. So to factor it, we need to come up with two numbers that multiply to negative 108 and also add to negative 12. It's a little annoying because negative 108 is kind of a big number. It has a pretty large amount of factors. One thing that we can notice, though, is that our two magic numbers are going to be opposite signs. The larger of the pair needs to be negative because it needs to match with the sign of this middle number. So, okay, negative 108. So 1 times negative 108, that's not going to work. 2 times, you could use your calculator, negative 54, that adds to negative 52. 3 times, I should have a calculator out, shouldn't I? I think 14, no, 28. 108 divided by 3. Oh, man, I'm dumb. Well, I shouldn't say that. I'm not dumb. I made a mistake. Okay, still not there. So 4 times, so let's see what's 108 divided by 4, 27. So negative 27. 5 doesn't go into 108, but I believe 6 does. Might have been easier to just do the quadratic formula. Oh, this is going to work. Thank goodness. Okay, 6 and negative 18. Those are our two numbers that we want to use. So we can factor this thing as x plus 6, x minus 18. So setting each of these equal to 0, we'll get x equals negative 6 and x equals 18. Whew, goodness. Okay, now here's the thing. Thinking about what the heck we were doing there, which it's easy to forget, we need to remember that our x is supposed to be the side of a triangle, and it was the A, the shorter leg. And it doesn't make sense for that to be a negative number. We never would say this triangle is negative 6 meters long on this side. So the only reasonable answer we're getting here is the 18. So our A is going to be 18. Okay, and then that means for B, we said we have to add 6, so 18 plus 6 is 24. And then for the C, add another 6, or if you like 18 plus 12, but you'll get 30. And you can check and make sure that works by just seeing, does 18 squared plus 24 squared work out to the same number as 30 squared? So just make sure those three numbers for your A, B, and C actually do satisfy the Pythagorean theorem. And then you should be good.